start, so don't forget to do that. So far this week, we've talked about networking. So we've talked about, way back at the beginning of the week, we talked about having two computers on a network, having them communicate over TCP. We talked about a lot of different internet-related terms, networking-related terms. And then yesterday, we talked about extending that to a specific protocol that uses TCP behind the scenes, HTTP. And we had HTTP clients making requests to servers. We talked about a bit what goes into an HTTP request and response. And we ended up doing a little bit of work with Postman too. So moving beyond Netcat and using actual tools that real developers use. So today we're going to talk about cURL, another tool that real developers use. And then we're also going to talk about Fetch, which is a tool for making HTTP requests in a web browser programmatically. So that's kind of the plan. Fetch is probably going to, usually it ends up being a bit challenging. We'll see how it goes. In general, I think this group's been doing relatively well, so we'll see. But that usually ends up being a bit challenging. So I wanted to leave you off with that before your break next week, so you have some time to think about it and process it. Okay. Let me share my screen here. So we're kind of going to jump back into the middle of what we were doing yesterday. So yesterday we went through Postman, and kind of the way I had set it up, we ended up moving on kind of to the next day's stuff. That day was kind of split between Postman and cURL. So here's kind of the cURL section. So as a review, we covered Postman yesterday. We're covering cURL and Fetch today. So what is cURL? So Postman is a tool for making HTTP requests that is graphical. So you open up this application here, and you can type into it and like fill out the form and click send, and it'll make a request. cURL is a tool for making requests in the command line, in the terminal. Just like Netcat, it has a bunch of flags and positional parameters that you use to tell the cURL command all the important parts about your HTTP request. So you can see there's 3 flags in particular that I want you to know about: -x, -h, and -d. -x means method, -h means header, and -d means the body. So the way cURL works is you give it all these flags telling it the different parts of the request you want to make. And then you also give it one single positional parameter, that is the URL you want to make a request to. Also worth noting is all these flags are optional. You can omit them if you want. So if you just do curl and then just your URL, then that'll sort of like make the request with a bunch of default settings. So in that case, like just like a web browser, it'll make a GET request with like no headers, no body, just like a plain GET request. So here's kind of an example of what curl looks like. I'll do a little demo here as well. So I'm going to make a request. Remember from yesterday that fruit endpoint we had? So that like careers encode.xyz/fruit, and that returned like a text string back. So we'll type curl in my terminal. I'm going to do -x, sort of following the parameters here, get. I don't have any headers, so I'm going to omit those. And I don't have any body. It's a get request, so I'm going to omit that. And I'm going to put my URL, http://careersencode.xyz/fruit. Then if I hit enter, I get back my response, which is kind of cool. Also, the cool thing you can do with curl, kind of above and beyond, but sometimes useful, is if you put a -v, that's another flag you can give it, it'll actually print out what it's actually sending behind the scenes. So you can kind of see here, this is the HTTP request it's sending. This is the little caret, the pointing the one-way caret. And this is sort of the response that it gets back, so the caret pointing the other way. So it's kind of, hopefully this maybe draws some parallels to what we were talking about yesterday. Okay, so I'm going to really only touch on curl briefly. And the reason why is it's probably not a tool you're going to use day to day as an engineer to like make requests for like testing, debugging, things like that. I'll say, just for full transparency, I actually do use curl every day. Like, I don't use Postman professionally. I have never really found it to be that good of a tool. I much prefer all the crazy terminal programs. So I actually do use curl on a day-to-day basis, but I recognize I'm a little weird. And I think if you were to ask Max, he would say he uses Postman quite a bit, like professionally, and also try to push you in that direction too, which I think makes a ton of sense. So you might be wondering, why am I talking about this? Really for one main reason, and it is that curl, that sort of like command, is often used as a way for engineers of different types to talk about HTTP requests. So here's an example. Let's say I'm working on a web application, and I make a request, and something's not working right. What I can do is I can take my request, and I can make a curl out of it, and then send it to somebody. And that's a sort of like the industry standard way to sort of communicate like a request. So to say like, I've got this request, it's not working. Someone can take your curl, they can run it, see it doesn't work, and they can sort of inspect it and understand, oh, okay, this is sort of what you're doing, what you're including. It's a lot more precise than being like, I made a request to this URL with these headers, with this body. It's also like self-executing. You just give it to someone, they can run it and replicate your problem. In addition, so there's that, which is kind of cool. Postman can both import and export curls, which is really where this starts to get pretty cool. So as an example, I have a request open that we made yesterday. This GET request for /apples. In Postman, there is this bar on the right, this vertical bar. And on there is sort of a greater than slash or less than slash greater than, which looks kind of like an HTML tag. If you click this, you can select all these different programming languages you want Postman to try to export your request as. So you have a lot of kind of interesting things in here. But the one that is going to be most interesting right now is curl. So what you can do is you can take this and it'll give you your curl. So this is something where, let's say you're making a request. It's not working right. You might come to me and be like, Ryan, I want some help with this. And what I'm probably going to tell you is, can you give me a curl the request you're making? Because that's a really easy way for me as an engineer to be able to like look at your request by eye, or to try to run it myself and be able to replicate your failure. So if you can give me that curl, I can easily replicate your problem and give you pointers on where to go next. That's really why I'm talking about curl, for that ability. Does that make sense? Any questions about that? Okay. There's one more other cool thing you can do, but with curl and Postman. But before I do that, I'm going to update this to be a different request from yesterday. It's a bit more complicated, just to show you sort of have a bit of a better example. So I had this like echo request we made yesterday. You can see that I sort of have like a curl it generates for me from that. So let's say for a second that someone just sent me that curl, like someone sent me this curl in like Slack or like an email, and I want to make this request. I mean, one way is I can just go to my terminal and I can just paste it, and that'll work. But that doesn't work so well if you want to like play with it or change it, or also if you're just not very comfortable with curl. So the other thing that you can do with Postman, if you go to the file menu up here and you go to import, you can actually paste a curl into Postman and it will import that curl into the program. And if I click send now, it'll make the same request that was made in the terminal. So with this, you don't really have to have a deep understanding of curl. You can just sort of use it opaquely, like export it out of Postman, send it to somebody. If someone sends you a curl, you can import it into Postman, and then you can poke around Postman and be like, oh, okay, I got to include this body. it's using this method, this URL. So that's really what I would like to, we're going to do a fair amount of that. Just as we get further along, we're going to need to do debugging and stuff. So that's really what I'm talking about, the curl. I kind of just covered this. So most likely you're going to want to use Postman. Most people like Postman the best. It's the most intuitive. That being said, both Max and I are fluent in both Postman and curl, so we can work with whatever you give us. That being said, if you give me a pasted curl versus like a Postman screenshot, I'm going to be able to help you a lot faster because I can just import that into a thing or can look at it by eye. With your Postman screenshot, I've got to like try to decipher it. You might have a tab hidden, and I got to be like, can you send me another screenshot with this thing visible? So the curl way for debugging is definitely superior if you can do it. Okay. So just for practice, just so that like everyone give it a shot on their own once. I'm gonna say, let's do this one. Here's a request. I would like everyone to try to make this with curl. I also just am going to add to this because I don't think it's very clear. So open up the terminal on your end, give this a shot. And actually, I'm going to also take a quick screenshot of this to include it in, just so we've got that as reference. Oops, not that one, this one. Here, give me one moment here. Sorry, I should have been a bit more prepared. There we go. So give this a shot. I think yesterday the whole thumbs up thing was working pretty well. So give me a thumbs up reaction if it works for you, or feel free to reach out if you're having difficulty. I'll give you a few minutes.
I have a question.
Yeah, go for it.
Yeah, so I wasn't like here yesterday, but I did look at like the video and stuff, and I kind of like don't understand like the steps, how to like how you get the host and stuff. Can you like explain that to me like one more time? Or give me like kind of like the short summary of things.
Can you say that the subject of that last sentence one more time? Sorry, I didn't
Uh,
quite.
I meant like how to like um what do like the terminal with the post method and stuff. I didn't really understand.
Yeah. Um. So yesterday we talked about making requests with Netcat, and then we also talked about Postman. Um. I guess it sounds like you're asking about the Netcat stuff. Okay. Um, really high level. It might be best if you want to go deeper on this to set up some one-on-one time. Like I can sort of go through it again, but really high level, what we did yesterday. Um, see if I can do this without covering the thing for everybody else. Um, so on Tuesday, we went through the exercise of running netcat as a client and a server and having them talk back and forth between each other. Really, the only difference with what we did yesterday with Netcat is instead of having Netcat as a client, we used our web browser as a client. So the HTTP is sort of the protocol that web browsers speak that we talked about yesterday. And if instead of using your Netcat as a client and you use a web browser as a client, then the web browser will connect to Netcat running locally. And then you can actually see the request coming in. And then similarly, if in Netcat you paste the right thing, it'll send a response back after the web page. And because you're speaking HTTP at both ways, sort of like you can perform that interaction. You can like, so I guess like there was, I'm going to see if I can quickly find it. Yeah, here we go. So down here, if I run a web server, or sorry, run Netcat listening, and then over on my web browser, I go to localhost 80 and hit enter. What ends up happening is this sort of thing gets printed here. It's because the web browser is making a request to the Netcat thing running. They're over that TCP socket, just like on Tuesday. It's just instead of Netcat doing it on the client side, it's the web browser doing it on the client side. And then I can paste back a response in there in Netcat, and then the response shows up in the web browser. So I'm sort of doing both sides of that. As for all the actual like bits and pieces of the HTTP request we talked about, there are a bunch of them. I think that would probably be better for me to go through in detail kind of in a separate thing. But like hopefully conceptually that kind of makes sense as to what's going on with HTTP. I think if you just sort of like just think of everything that's being included as parameters to like curl or Postman as just being parts of that request, that's probably good enough for now. And then if you want to set up some time, we can go into like actually what they all mean. Is that helpful? Sorry, I kind of tried to do that really quick and probably didn't do a great job.
Yeah, it was. Yeah, yeah. It made sense a little bit.
Cool. How are folks doing with this curl stuff?
Can you show us the syntax again? I forgot the
Yeah.
order of them.
So here's an example curl. Keep in mind that the way that command line tools work with the flags, you can put these flags kind of in any order. So if you remember from yesterday, we sort of have like the key, the name part of the flag and the value after it. So I'm actually going to take this and include this on the other slide too. Where is it? Okay, how are folks doing with this? Do you think it'd be helpful if we go through this together? Okay, seeing some head shaking. Let's do that. With my terminal up here. Okay, so I'm going to just generally follow this as a template. I'm going to use this sort of as a reference for what each part means. So I'm going to start just like every other curl command, or like every other terminal command. You start with sort of the name of the command at the very beginning. So curl. So next, we've got this -x post. And if you look down here, -x post means the method. So our method's post, so I'm still going to do -x post. That's what I want. Then after that is -H. So looking down here, I see -H. That refers to request headers. So if I want to include extra request headers in my curl, like custom headers, just like I would with Netcat with typing them in, or in Postman with typing them in my request, I could put them there. In this case, it doesn't look like we've got any custom headers we need to include in this. So I'm just going to omit that. In general, like just like we did yesterday, some requests don't have headers, some do. Just sort of is what it is with some do and some don't. Okay. Then -D, optional request body. So -D, the request body. It does look like we have a request body. The quick brown fox jumped over the lazy dog. So I'm going to do -D, the quick brown fox jumped over the lazy dog. I do want to quickly point out something that's a little unintuitive here. What goes in these quotes is sort of all the parameter for -D. It's sort of like the quotes end up meaning that like these spaces are kind of irrelevant in the whole like figuring out what goes with what thing. So that's kind of what that means. It's sort of like a thing you do in the terminal sometimes. I didn't call that out. I probably should have yesterday. Yeah, you have the right idea. It makes it a string. So it's very similar to in JavaScript, how you put the quotes around it. Note that you'll see me use single quotes and not double quotes. It's just kind of like a terminal thing. There's a reason why I do it. It's not that important, but like in general, that's what we're going to use. Okay, so we've got -D. And then after that, it looks like you've got our URL. So the kind of thing we put in that URL box in Postman. So if you remember from yesterday, we sort of build our URL from a bunch of different parts. So looking here, http:// our URL starts with the protocol. We're still making a request over HTTP. That's what we're going to be pretty much doing for the rest of what I'm going to be teaching you for the next today and the following week or in 2 weeks. And then after that, we have our domain name, our host name. So careersencode.xyz, just like yesterday. And then after that, we have our path. So those are sort of the 3 parts of the URL we talked about yesterday. And our path is text processing /frequencies, something kind of like that. So if I hit enter here, I should get back this, which should look kind of familiar from yesterday. We've made this request to with Postman yesterday. Any questions on that?
No, but that helped me. I was forgetting to put careersencode.xyz before the path. Just throwing the path on the HTTP. But
yeah. Yep, you need that host name. Otherwise, it doesn't know where to send that request to. It doesn't have an address on the letter.
And you mentioned that like capitalization like counts, right? Like so
Yep.
if I put a dash capital X, it will like still count because I kind of messed up on mine. Says cannot resolve proxy post. I think because I put like a lowercase x. I'm just not sure if it. Like,
Yeah, so capitalization is very important in
okay.
general with I mean, I might make the statement in general in software engineering, but like definitely with this stuff, it is. I also should mention just real quick that like these flags we're using are sort of like the short flags. There's also some other flags you can use that curl has that do the same thing. You might have actually seen what Postman exported here. These actually use some of the longer flags like header and data instead of dash uppercase H and dash D. I'll be honest, I'm kind of surprised it does that because these are the much more common ones, but I don't know. Any other questions? I think it probably makes sense to do one more, just since we went through this one together. It sounds like a lot of folks could use the extra practice. But if we're going to do that, I just want to make sure I give any room for any questions first. Okay. So if we're going to do that, I'm going to... I don't know why I didn't include the... Yeah, we'll do this one. This one's very similar.
And then I have a question afterwards.
Sure. I mean, feel free to ask now if you think it's relevant.
Yeah, it's related to Postman. Looking, I do see that there are various options for the body. For example, there's raw, I believe, and binary, as well as some other things. And I'm just wondering what the differences are there.
Yeah. I'll just quickly say, if you have this up on your screen, feel free to give it a shot. I'll try to not cover it, but I can only do the best I can here. So you're talking about this stuff right here, all these options. Cool. Yeah, so none sort of just means like empty body. Form data and XWWW form URL encoded. These are sort of, I guess, how would I say this? Like ways of encoding data in the body. So let's say you wanted to put more than just like a text string in your body. You wanted to include some more like data that was formatted in a bit more of a complex way. These are sort of both two different ways you could kind of handle that. If you want to play around with them, actually, if you go over into it and you like under key type like something, and then under the value type something. So like I sort of entered a thing in there, and then you select raw, or wait, how do I do that? I guess you could do it also by looking at the export. Yeah, that works. So like you can actually look at the curl export and be like, oh, that's what the body looks like. And so you can kind of, if you're curious, like actually see how it's doing the encoding. I'll say that I mentioned yesterday that we're not going to be using either of the only ones we're going to be using in class are none and raw. I guess I should also say binary, to be clear, is like, let's say you want to send as the body of your request, just like arbitrary ones and zeros. So I don't know if Max has talked about it, but like in computing, like binary is a big deal. It's how all data is represented. And what your text is behind the scenes is really just a sequence of ones and zeros. Every character is a byte, 8 ones and zeros. It's represented with this thing called ASCII. It's like a way of encoding text, or actually, I guess Unicode now, but ASCII for the most part is still relevant here. But like, you're effectively encoding your text into binary. So there's kind of one more step removed where like, let's say you wanted to like, as the body of your request, you wanted to like include like an image or something, which that image is like not text, it's like other binary data. You could do that by selecting binary and then like selecting a file to upload. So again, we're only going to be using none and raw. And I think actually I'm going to use binary once in a few lessons just to like test out a thing. For like, the reason why we're going to be using raw is because we haven't actually talked about more complicated ways you might want to encode data in your body. And we're not going to be using these two mechanisms for encoding data. We're going to be talking about another one, like mid to late the week after break, so we got a bit to go on that. But yeah, so I guess this is all to say that like that hopefully was a good summary of like what all these things are. We're only going to be using done and raw, and those are the only ones you have to worry about. But if you want to play around with the other ones, feel free. Any other questions there? Okay.
Yeah. Yeah. Mine is not working. I don't know why I'm going wrong.
You want to share your screen and we can take a look?
Yeah, I was trying to go from here, but I keep getting this.
I think you're pretty close. So you have I think I can doodle on your. There's like a way I can draw. Annotate. There we go. Yes, that works. Excellent. Okay. So you have curl there, so that's good. And then after that, you have -x posts, so that's the method. That's good. After that, you've got -d and then your body in single quotes. I think you might be missing the word dog at the end of your body, but that's not that big of a deal. You're still making a request to the valid body, and that's really what's most important. So everything other than that one missing word looks great. However, after that, you have this. So you've got for your URL, you've got your protocol. That's good. Your domain name, I think you meant to say careers in code, not career in code. So again, like very close, but I think you're just missing that one character.
Okay.
And one other thing to call out is right here afterwards, that should be the path. So text processing frequencies. It looks like you missed a few characters. So you did like career encode.xyz space, and then like it should be careers encode.xyz slash text processing slash frequencies. So
Okay.
I think you've got the right idea. I think you just might have a few typos, and if you fix those, it'll work.
Okay.
Does that make sense? Cool. I'm seeing a fair number of thumbs up in the chat and in reactions from folks. So I'm thinking that probably this is good. If so, I think we're probably going to move on to fetch, because that's probably going to be a lot more involved, and I want to make sure we have time for that. But I guess I'll say it one more time that like, while it's good to know curl, to be exposed to curl, I don't expect you're going to need to use it day to day. You're going to need to have deep knowledge of it. It's really the reason why I want to expose to it is because of that important export behavior from Postman. That is sort of like the thing that uses curl. So really, like, you can think of curl as like an opaque import export, like, or I guess rather an opaque way of representing a request as a text string that you can sort of send to someone that they can then use to parse and re-understand it on their end. Okay. So now we are going to go to the real topic for today. So Max, when he last was talked to you all, mentioned the New York Times bestseller project, or he called it like the midterm, sort of like this this project we're going to do at the end of the section I'm teaching here. So because we're now going to start to actually talk about some stuff that's going to be quite relevant to it, I want to show you now what this project looks like, so you can start to think a bit about, like, put it into context what we're going to be talking about today as to how it might fit into this project. So this link here is a deployed version of it I put together a while back. And what this project is it's a web page that shows a list of all of the New York Times best-selling books. So when I load this page, it's sort of like what it's doing behind the scenes is this isn't just like a hard-coded page. Like I didn't go in here and like hard-code a bunch of books. What this is doing is when the page loads, it's actually contacting the New York Times. It's making requests to the New York Times, and it's getting information about all of these best-selling books in the response back from the New York Times. And then it's using that response to actually render all this information about the books, sort of in like a rich sort of format where you've got like images and labels with like author names. You've also got links here that are like Amazon links you can click on that'll bring you into the books page, so you can actually like learn more about the book if you want. So this is sort of, if all goes to plan, what you all will be working on at the, not next week, the end of the week after next week, once you're back from your break. The reason why Max kind of has talked about this as being the midterm is because it kind of touches on everything you've done in Careers in Code or will have done up to the point of the end of the 2 weeks. So HTML, CSS, you have to sort of style this and make it look kind of pretty if you want. JavaScript, you've got to run code on the page to be able to make all this happen, and all the networking stuff. So we're going to have to talk to the New York Times, figure out how to do that, and then get back the response and sort of use that to render this page with all the information. So you're welcome to go to this on your own, check it out. But I just want to kind of give you a preview of where we're going, kind of like the light at the end of the tunnel, so you can keep an eye on that as we go through things today. Any questions on the New York Times project before we keep going?
Do we have to make it exactly like that, or can we like style it on our like own, or how's that gonna?
You can make it look however you want. I think the way that I define the requirement is like, or the goal for the project is like, at a very minimum, you can just have it like dump a bunch of text onto a page, and that's fine. Like that's sort of the minimum bar. And if you want to make it look fancy like I did, you can do that. And I'll see if I can try to dig up some other students' past versions of this from previous cohorts. But like some students really end up going all out. I think I remember one student one year did a thing where they had like a select box where you could like this little title here, since there's like sections of these different like best-selling lists, they had a little select box, you can click on it, and you like select the one you want, it would like swap them out, so it would be able to see like one list at a time. So like some students go crazy down the rabbit hole and like customize it and styling it to their heart's content. Others are just fine with like, here's the raw data, that's all we're doing. And either is fine. Either proves you understand what you're doing, so I'm cool with it.
Now would it be cheating if I looked at my my brother's then, because he was in the past cohort, so would it be cheating if I like do that?
I mean, I would encourage you not to, but I would also encourage you to ask your brother to see what he remembers, because he might have some thoughts about the project. Cool. Okay. So we talked about Postman, we talked about curl. Now we're going to talk about fetch. So fetch is a JavaScript function built into modern web browsers that allows you to make HTTP requests dynamically in the web browser. So this sort of tool, fetch, like kind of where it sits in sort of the technology sphere. There's a few other tools you might come across that are very similar in nature. I'm just going to mention here, mostly I'm putting this here so that if you look back at the presentation later, you can sort of draw the correlation. But jQuery Ajax used to be popular years and years ago. It's used a little bit less now. Axios is an NPM package that people use quite a bit and is very popular. Request Promise also is kind of another somewhat popular one. So why are we using fetch? So fetch is built into the web browser. So what do I mean by that? Well, I'm going to open up a new tab. I'm going to go open up my developer tools here. I'm going to go to the console. So as you probably all know, I can type JavaScript into this console and it'll execute. So hopefully that's not new. But fetch is just a global function available in every modern web browser. So what's nice is we don't have to worry about bringing in some sort of package or dependency or extra tool to be able to do this. So we can just sort of use fetch. It's global, it's built on the web browser, it works everywhere, pretty much everywhere. So it kind of is going to make it easy for us to do all this work today. We don't have to worry about extra stuff. All these sort of tools like fetch, like Axios, like all the things I mentioned before, they all sort of have a lot of the same concepts. So it'll relatively transfer, but we're just going to use fetch because it's the easiest to get started with. So that's kind of what I just said. So fetch is a function, JavaScript function, that takes two parameters. The first parameter is the URL you want to make your request to. So this is like what went in the box in Postman, this box here, what was sort of the positional parameter in cURL. So we've got our protocol and our domain name and then a path after it. The second parameter is a bunch of options that you can include to fetch to tell it how to customize how it's making the request. So here are the three that I think are the most important you should really know about. There are others, but we're not going to really talk about them today. So the three I want you to know about are method, headers, and body. So keep in mind, this is a second parameter that you pass to fetch. It's a JavaScript object. So it has key value pairs inside of it. Hopefully this should look familiar from your time with JavaScript. These sort of keys are just like built into fetch. It just knows to look for the data there. And then these values sort of should look relatively similar to what we've talked about. So we've got a method, we've got our headers. Note that the headers, the value is another object. So you've sort of got like two objects deep here, which is a little tricky syntax-wise. So headers is the key, the value is this object, and then within it, we've got this key authorization and this value super secret. And then also the body. So body is the key. And then the value is just the string you want to put into the body. Keep in mind, this is JavaScript. So we're putting double quotes around all of our strings, passing them in the right spots. This is how the parameters being passed in break down to sort of that like raw netcat format we were talking about yesterday. So you can see here that like the path gets stuck there, the method gets stuck there, our headers get stuck there, and our body gets stuck there. Fetch has a few different default values that you should know about. So why are these important? Well, let's say you were to make this request here and leave the second parameter either just an empty object or just omit it altogether, like this, for example. Fetch will still work. It only requires you give it that first parameter. If you don't give it that second parameter, it's going to assume you mean a GET request. If you've noticed, everything kind of tends to, in the HTTP world, assume if you don't include a method explicitly, it means GET. So that's kind of what the web browser does by default. That's what Postman kind of does by default. That's what cURL does by default. And now it's what fetch does by default. Headers, if you don't include explicit headers, it's going to assume you don't want any custom headers. If you don't include a body, it's going to assume you want an empty body, or kind of in the Postman parlance, like you imagine you had like none selected here. So it's just not going to include anything. So whenever you make a GET request, you don't want to include that body key in that second parameter. Okay. So before we move forward, I'm just going to put this up again. Any questions about this sort of fetch syntax? I'm gonna make a request in a second here to actually give you a demo, but I want to give you a chance to ask any questions first.
Yeah, the authorization goes into quotes too.
Yeah, good question. So technically, these aren't required. When you have an object in JavaScript, keys around the quotes, if the keys are like all letters and numbers and I think underscore, like if it's sort of within that supported character set, you don't have to have, and a space, like if you want to have a space in your key, you need to put quotes around it. Like if you are able to have a key that's only letters and numbers and I think underscore, like you don't have to put quotes around it. I'll say that I think I just put these here by convention, but I don't think they actually would be required in this case. Any other questions?
So, correct me if I'm wrong. So when we use fast, so fast is just pretty much, are we like taking the data from the website and put it in our JavaScript, or?
Yeah, so in JavaScript, you're sort of running tasks. You have a bunch of different commands that you run in sequence. And I think this is going to make a bit more sense once I actually do this demo here afterwards. So maybe I should just do that and shut up. But like, what you can do is just like you might call a function. Let's say you have like an add function that you give like 2 parameters to add numbers together, and you get a result from that add function. In a similar way, you can call fetch, and you can give it all these parameters, the URL and the method headers and body. And then the value that fetch gives you back is the response. So you can sort of insert that in your program. And now all of a sudden your program can interact with HTTP, we can make HTTP requests and interact with other web services online. So it's sort of like another way you can get data into your program. And it just so happens to be a pretty handy one because a lot of services will expose data over HTTP. Did that answer your question? Cool. Joe, you said in the chat that Prettier would probably remove them if you didn't need them. Yeah, it probably would. Yeah, I think it probably would. Okay, so what I want to do is I'm going to start by just writing a fetch in here, just to sort of see what that looks like. After we get a little bit further, we're going to actually write them in some distinct HTML files so we can run them over and over. But I just sort of want to do an initial demo here to get started. So I'm going to type fetch, and then I'm going to make my request HTTP. Okay, it's going to auto-complete it for me. So just like yesterday, I'm going to make that request at fruit endpoint. And then I'm going to make the second parameter here. And in there, I'm going to put method get. I don't want any headers. So I'm going to include everything just to be explicit for right now. And body, I don't need a body because this is a get request. Okay, so I've written out my function here. I'm going to store this into a variable. I'm going to go like const response equals something like that. Okay, hit enter. Oh, okay. I kind of outsmarted. I'm just going to omit body. Okay. So I hit enter. Okay. So what just happened here? When I hit enter, the web browser made a request to this with get, no extra headers, and then it got back the response data, and it put that into response. So I'm going to hit response, and we're going to see, so you're going to see this thing called a promise. This is where we kind of touch back on some of the stuff that Max talked about on Monday. So fetch is a bit different from a lot of other things you've done in JavaScript so far. In JavaScript so far, you've run a lot of what's called synchronous code. Also, I might be reviewing some of what Max has talked about with the promise stuff. If I am, just let me know. I can kind of skip ahead. I just want to make sure I cover this in case he didn't. So what you've done a lot of so far is run synchronous functions and write synchronous code. Synchronous means code that is able to immediately give you back a result. So a great example, I'm going to write here a function called add. I'm going to give it 2 parameters, a and b, and I return a plus b. Hopefully that should look pretty straightforward to things you've done. I'm going to go add 1, 2, add returns the value 3. Great, does exactly what you'd expect. This is synchronous code. When I run that add function, it's able to run the code immediately, give me back a result immediately. So I hit enter, it gives me back 3. There are certain functions that aren't able to give you back data immediately. So the example Max talked about on Monday, he used a function called setTimeout. So this is an example of an asynchronous function. SetTimeout, you can think of it as a way that a JavaScript function that will delay for a certain amount of time before it gives you back a result. If you think about that, like one way that could work is you could run your function. Like imagine this is not real JavaScript, but I'm just going to like type this out as an example. Delay. Oh my gosh. And maybe I give it like 1,000, like 1,000 milliseconds a second. One way this could work, this isn't how it works, but one way it could work is we could have this global delay function. And you give it 1,000, so like 1,000 milliseconds a second, and you hit enter. And then what it would do is it would sort of just like pause, like just sort of like grind to a halt, pause for a second. And then once it's done, it would sort of run the next command. So you could think of this working where like maybe you had like a console.log and then one of these delay functions and then like a console.log after that. So you'd get like the first log, you'd wait a second, and the second log. So this could be how it works, and actually is how it works in a lot of programming languages. But there's a real problem with this approach, and that is that JavaScript only has one sort of line it can focus on at a time. It's what's called a single-threaded environment. That's kind of the fancy word, but like what that really means is it's only running one command at a time. So I'm actually going to open up. I need to actually get this in an editor. I don't want to just hand wave anymore. Okay. So let's see. Oh gosh. I want this to be JavaScript. Okay. So something like this is sort of our like our delay example. Okay. So if JavaScript is a single-threaded environment, which means that if this were actually running like we were talking about, it would run this, so it would log out first, then it would go here and it would be stuck. It would like block, it would wait. And the reason why that's a problem is because while that's blocking and waiting, what would actually happen is the whole web browser would lock up. It wouldn't let you interact with it. And that would provide a really poor user experience. Imagine anytime you had like you wanted to wait. And a great example of like where you might want to wait is like, let's say you're like doing an animation. You're like, okay, move this up. Wait a second, move this over. Like that kind of thing. We're like, so there's definitely times where you'd want to wait. This isn't just like a contrived example I'm making up. I mean, I guess it is a little contrived, but like this is something you would really want to do. So if you are waiting and it's just like blocking the whole web browser, it's going to grind to a halt. It's going to lock up. The user's not going to be able to use it. And that's not going to be good. So because of that, this approach does not work in JavaScript. You can't block. You never want to block that main thread. You never want to have that execution pointer stop moving. Like you always want it moving, always want it running the next thing. So how do we accomplish this? Well, in JavaScript, there's what's called an event loop. So an event loop, what it effectively is you can sort of like tell you can tell JavaScript behind the scenes to run things later. So I'm going to switch this out for what the actual code would look like. And then we're going to sort of move back over to promises. But I want to sort of give you like an idea of actually how you'd accomplish this problem, how you'd actually do something asynchronous. Oh, I guess I didn't say that. So this problem here, this is an example of asynchronous code where you have like, you want to be able to return a value, I guess like this. You want to be able to get this value, but you can't get that back immediately because like the delay, like that would cause the function pointer to get locked up. It would get stuck on line 3 and it wouldn't be able to like keep moving on, which would cause the browser to get locked up. So like this whole approach wouldn't work. So the way you actually do this in JavaScript, there's a function built into the global scope called setTimeout. I think Max used this. He talked about it a bit. So setTimeout, it takes 2 parameters. It takes the first parameter is what's called a callback. The second parameter is the delay in milliseconds. The second parameter is just kind of like this parameter here. So I'm going to just like, for now, just put a placeholder there, and I'm going to put like 1,000. Stick that down there. And then, oops, stick that up there. Okay. Now, the way setTimeout works is setTimeout, the return of setTimeout is kind of weird. It's not really, with a function like this delay function up top, you're sort of like, when this function completes, that's sort of assumed to be like when you move on to the next thing. With setTimeout, that's not true. And this is generally how asynchronous code works. When you have a function that's an asynchronous function, the return value can't just be like the value that will come eventually. It can't just be that value. Instead, you have to come up with some sort of special trick in order to handle that case that like the value is going to come later, but it's also still allow that thread pointer, allow that function pointer to keep moving, that like where you currently are. So the way that setTimeout does this is it uses this thing called a callback. This is where it goes where these X's are here. So a callback is effectively a function. And what will happen is setTimeout, instead of returning and then the next line running after 1,000 milliseconds, what it will do is setTimeout uses that machinery I talked about in JavaScript, that event loop, to schedule this function to run later. So what that means is, actually what I want to do to get the behavior I want is I want to stick this log here inside of the function. So let's walk through what's going on here, and then I'll actually run it, and you can sort of see it execute. So on line 8 here, we start by logging out first. So we get that log in the console, it says first. Then I call setTimeout, and I give it 2 parameters. The first parameter is this function. The second parameter is 1,000. setTimeout is able to look at this and say, oh, 1,000? Okay, I will schedule this function to run in 1,000 milliseconds. And that's what it does. It sort of puts that aside and says, okay, in 1,000 milliseconds, I want you to run that. And then it immediately returns. And you could sort of like, now at this point, the browser is just sort of like free to do whatever. You could have more code down here if you wanted. The browser could be free to handle events. Maybe you have like the user clicks on a button and need to handle that event. Maybe the user resizes the page and it's got to like reflow all the stuff on the web page. There's a lot of things the web browser could be doing. But importantly, it's not just blocking and waiting for like that delay to be done. And then in the background, the web browser eventually is like, oh, okay, a second has passed. I'm going to call this function. And what it will do is it'll call that function, and the function pointer will go to line 10, and then it will log out second. So it's a really subtle difference between like waiting, like blocking on the function, like the delay function, and scheduling the callback to fire in a second. They result in generally the same outcome, but how you actually get there is different and like notable in that the second one allows the browser to always be responsive and always be able to handle events coming in. Joe, you asked a few questions. Do you always run an unnamed function in the first parameter? So I do want to quickly call out that I'm not actually running this function here. I'm just sort of giving that function to set timeout. The reason why they call this a callback, that sort of lingo, is because I'm giving this function at set timeout, and set timeout is actually, well, I guess really the web browser, but like the web browser is going to call this function. I'm never actually going to call this function. It's going to get called by the web browser. So I'm going to get called back once it's time for me to return or get my value out of the thing. So, but to answer your question, I think like what you're getting at is like, do the way these callbacks work, do you always stick this as the first parameter? No, you don't. They're kind of inconsistent. You sort of have to look at the documentation for the function you're using. And we're going to talk about in a second the way fetch does it, which uses promises, which is a little bit different. But for that to really make sense, we got to like talk about this first. You also asked, does the event loop track on server side or client side? So the event loop in general is a JavaScript concept. Well, I mean, it exists in other languages too, but like, I guess what I'm trying to say is in every JavaScript runtime, there is an event loop. So if you're running JavaScript on the server, there's an event loop. If you're running it on the client, there's an event loop. Importantly, every like instance of JavaScript will have its own event loop and its own whole state there. So if you're running JavaScript on the client and JavaScript on the server, you've got an event loop on the client and an event loop on the server. Okay, I just said a bunch of stuff about how all this delay stuff works. I want to open up the floor if any folks have any questions. This is kind of nuanced and complicated, and anything that you might have, I'd love to answer any questions. And also, if you're just very overwhelmed, feel free to say that too. I don't really know how you all are taking this, so any feedback would be helpful.
Can you do a live share on your
Oh yeah. Crap, I always forget you can do that. I think it's this button. Yes. Okay. Okay, I think now what I want is that. I'll be honest, I'm not super familiar with how live share works, and every time I screw it up a little bit, so hopefully that worked. Try to connect to it and let me know. I did, though, say I would actually run this to show you how it works. I didn't do that yet, so I'm going to do that. So I'm going to paste this in here, and I'm going to hit enter. So if you see there, I get first, and then I get second. So like it waits a second between each of those. And I could make that 1,000 maybe more like 5,000. So first, and I'm waiting about 5 seconds. And then we get second. So that's kind of how that's actually operating there. Any other questions? Okay. If I'm not getting anything, I'm going to keep moving forward. But please, if you're having difficulty, stop me. I would love to. Okay, yeah, you might have more later. Yeah. Okay. So
Uh, this
yeah,
one's different in the live share than what you have on your screen. I don't know if I'm just in the wrong place. You want to see?
sure. What?
I know, right?
Yeah, I definitely have that too.
That
Different link.
what the heck is that?
I'm not sure.
Oh, Max's portfolio. Wait, um,
You go to something?
are you sure you went to the right link? Let me actually try to go to my link myself. I'm wondering if you maybe like auto completed and went to like a link that Max had live or something.
Oh, how do I get out this? Just exit it? But
Uh, wait, I have to prove? Okay, I guess. Yeah, okay, I'm seeing this. What the heck? Um, hmm. I wonder if there's some sort of setting I have to set specifically. Hmm. I'll be honest, I'm a little perplexed as to what's going on here. Maybe I'll try to stop and restart the live share session.
What is your what's your VS account name?
I have no idea.
I saw somebody as one ego man, I think.
That's me. Yeah, probably me.
Okay, I when I clicked to try to follow your cursor, it said you are not in a shared document.
Oh, maybe I didn't. Okay, when I opened up the thing, I had a different program loaded. I guess from something I was doing a while ago. I must have done it in that thing and not shared the tab I was in or something. I guess I didn't realize that mattered, but I guess it does. Good to know. Okay, so I'm going to oh crap. Let me get this back open here again. Okay, try that new link. Let's see if that works. How does that look?
I'm still seeing back in the same folder as React portfolio.
Oh, you know what? Okay. Um, it looks like that's just, well, let me share my screen. I'm sorry, folks. I'm gonna need your help to debug this because I don't have as much familiarity with live share as I probably should. So it looks like I have this open as like the directory. I just haven't saved this file. So what I'm gonna do is I think I'm gonna go new window. It's like unassociated with any folder. And then in here, stick this.
Yeah, I was gonna say maybe like try like a new folder and like open it
Yeah.
through that folder instead.
Yeah, do something like that. So now if I do a live share, I think that might work. So if I go to this here, Uh, so like,
I don't know why I can't see those files. It says I'm in there.
like, oh, wait, no. Maybe I have to actually be in like a directory for this to work. Let me, okay, I'm gonna like,
Usually when Max is doing it, he makes a new folder, opens the folder, then starts creating the files in there.
okay.
I don't know if that order has any reasoning, or
Yeah,
if he's sharing the folder instead of a specific file. I don't know.
it's a good point. Um, okay. Ooh, wait, no, I don't want that. I want this. All right, so if I go over here, then there we go. Okay. Yeah, so okay, it looks like the resolution here is you have to make a directory, you have to put a file in that directory, and then at that point you could do the live share. If you don't do either of those steps beforehand, it just doesn't work. Good to know. Thank you for bearing with me there, folks. At fourth try link should be what you want. Excellent. Okay. So now we've got that going. If we don't have any more questions right now, I'm going to keep on going through. We're going to talk a little bit about how promises fit into all this and how fetch fits into all this. And then we're going to do this a bunch of times to get you all kind of familiar with kind of the process here. Okay. So I'm going to come back over here. And I'm going to write out that fetch. Actually, I'm going to stick it at the bottom. Let's try to keep this chronological. This is what I'd written out before. Okay. Come back over here. Open this up. This. So also gonna go response. So what I want to call out here is fetch is an asynchronous function. However, with fetch, I'm not giving it a callback like I gave set timeout. So there's a bit of a discrepancy here. Like I just said that if you have an asynchronous operation, and fetch is an asynchronous operation, set timeout is an asynchronous operation, then the return value from the function that's doing that asynchronous operation, like it can't just like block and wait. Like it somehow needs to like you need to like schedule that code to run in the future that like will operate on the return value or the result value. So how does that match? Like, why did I do the callback for set timeout? Why do I not have that for fetch? Well, because fetch is using this thing called a promise. So it's worth mentioning, like, I guess, also like why callbacks can get kind of annoying and why they can kind of suck. So let's say I wanted to do this, but instead of logging out just first and second, I wanted to log out like a bunch more. Let's say I wanted to go like first, second, third. So in order to do that, I have to do something kind of like this. I mean third. So what's happening here is log this out, call set timeout, pass it this function, and tell it to run that function in a second. It goes down here, it kind of waits around, does other things in the web browser. And then after that second goes by, it runs this function. And the cursor goes, the function pointer goes here. And it goes second, logs out second. And then we hit another set timeout. The whole thing happens again. So the set timeout runs. This function gets scheduled to run in the future in a second, asynchronously. A second, get that from there. And then inside of this function, this outer function, this outer function here, it's done with that. So it just sort of like exits out. It's done with it. It just sort of like handles other things in the web browser, other events, other web page reflows, things like that. And then after that, that a second's gone by, it then runs this function, which logs this out. So you get, and I'll run this just to show you, you get something that looks like first, second, third. So you sort of get them in a row like that, each with a second in between. And you can keep scaling this. We could add fourth, fifth, keep on going. But what you're going to notice as we do that, and I'll actually add a fourth just to make it even more obvious. Fourth. What you're going to notice is very quickly, our code is starting to go to the right as I indent it. So every level of function, I tend to want to indent over. And it's going to start going to the right a lot. And you'll also notice like that kind of is a little difficult to read, but also like this whole set timeout thing, it gets like very cognitively intense to be able to see like, oh, set timeout, this callback, and then you have to keep that in your head, keep track of all that stuff going on. It's very complicated. Engineers don't like things to be complicated if we can help it. So like none of this is like a deal breaker. Like you can work in a context like this, and in many cases you have to. But given that so much stuff ends up being asynchronous when you're building websites and web applications, some enterprising people tried to think of some ways you could make this asynchronous behavior less confusing and less hard to wrap your head around. And one of the better results of that, one of the better sort of innovations that came out of this is this idea of a promise, which is the goal with a promise is to try to solve this problem of lots of nested callbacks. You'll sometimes hear this referred to as callback hell, or sometimes pyramid of doom, because it's pyramiding to the right. Engineers like to think they like to come up with clever names for things. So what a promise does is it allows you to actually use the return value of a function that's asynchronous. And you might be thinking, well, how do you do that? Because that return value comes back immediately, but the result comes back later. So there's like an incongruity there. Like, how do you return a value that doesn't exist yet? Like, and that's kind of what a promise sort of lets you do. And I'm going to move back over the presentation now. We're going to start walking through this. I have a little like walkthrough that explains what's going on, and I think we'll put some things into perspective. So fetch uses promises to handle its asynchronous behavior. It doesn't use callbacks, it uses promises. And because it uses promises, it's able to return this promise to handle this asynchronous behavior. So here's how a request works when you make it with fetch, how sort of the asynchronous nature works. So we start by just making our request with fetch. So, oops, not that. I mean, this. So that's like this. This is like step one. We make our request and I guess assign it to response. Or wait, what the heck happened there? Assign it to response. So this is step one here. Next, once we call fetch, behind the scenes, inside of the implementation for fetch, fetch creates this thing called a promise. So Max used an analogy with you all about like thinking of it like an oven that like is baking, and like when the oven's done baking, sort of like the task is done and sort of like it's like complete. I'm going to go with a different analogy. We'll see. You might like Max's better. You might like mine better. My hope is between both of us, we'll get something that kind of sticks with you. The analogy I'm going to go for is a box. So imagine that you have a box, and the promise sort of is that box. When you create the promise, it's like a box that's empty. Like imagine like a shoebox with like nothing in it. And you create that box in code, you represent that, and then that gets returned from the fetch function. So this response here is actually a promise. Think of it like it's a box, like it's an empty box. So now, once that empty box is returned, we wait. So importantly, like I return something immediately from fetch, which I have to do because I can't block. If I have a function return value, it's got to come back immediately. But like I haven't, it's sort of like a placeholder return value. There's like nothing in there yet. So we wait. So what we kind of did here is I ran fetch and then stored it into a promise in this response variable, and it just contains a promise in that variable, that empty box. And pending means it's empty, doesn't have anything in it yet. And then eventually, let's say after a second, a response will come back from the server because that takes time. Sending data over that TCP socket, going through the wire takes time. It takes time for the server to process things and think about what it's going to send back in a response. It takes time for those packets to make their way back across the TCP socket. So eventually, after you wait a bit, the response is received. Once that response is received, it's put into that box that was returned in step 1b at the very beginning. So now our box goes from being empty to being filled with the data that's returned back from the server, our response data. So things like status, body, other sort of metadata like response headers could be in there. So in essence, this is kind of what we just did. I called fetch, I got a promise. That promise is pending. I waited a few seconds for the response to come back from the server. And then after it came back, after a few seconds, that promise, that box is now filled with something. It now has within it the response data. So that's how we can kind of work around this problem of you can't have the function block. You've always got to have that function pointer moving. It's always got to be running a line. You can't block, you can't be stuck on a line. That's how we sort of work around that, while also being able to take advantage of the return function for asynchronous operation. So Joe asked, is there a max time allotted for the promise to complete by default, or does it have to be specified? Good question. There is not. A promise can be pending, the box can be empty for an infinite amount of time. You can have a promise that's empty for like days and then gets resolved. In practice, promises tend to be resolved within like seconds. Like this tends to not be a thing that happens, but it could. There's nothing like that inherently means it can't. Sometimes certain functions will that are asynchronous will let you pass a parameter that's like max time that I can take. That's like a timeout or something like that. And if that happens, that might cause it to if it hits that timeout, stick a value in the box early that's like, I couldn't actually compute my thing, like, or run the computation you asked me to do. Like that could happen. In practice though, like promises can, like they can be pending forever. I think that's the answer you're looking for. Do the status codes dictate if the promise fails or not? Another good question. With fetch, they don't. With other libraries, sometimes they do. In general, if fetch, like the value or the response data will get stuck in the box properly as long as a response comes back, no matter the status code, no matter like anything about it, as long as data comes back, you'll get it successfully. Okay. So yeah, I guess I wanted to call attention to the thing in the red box here, like that section there, that body and status, like that's the data. That's what you got from the server. That's the valuable stuff you want to get. Okay. So, I guess I kind of already did this, but I want to use this opportunity to sort of set up an HTML file so we can actually do this repeatedly going on. I don't want to keep doing it in the JavaScript console, just I want to give you all like a file you can take away from the end of the day today that has all the stuff we've talked about in it. So I guess here's a question. If I make a new tab and I save a file, do you all have access to see it?
I can see it.
You can see it? Okay,
Mhm.
cool. So I don't need to like do another share or something. That's great. So I'm going to
No, sorry, I didn't mean to interrupt, but as long as you have that file inside of that folder, we should be able to like see it.
okay,
Yeah, as soon as you created the file, it jumped me over because I'm following your cursor.
excellent. That was my hope. I don't want to assume and get like 5 minutes down the road and have you all be like, what are you doing? So thank you for confirming that for me. Okay, so I'm going to start off here by laying out my file. This should all be stuff you've done probably like many tens, if not hundreds of times at this point. So I'm going to make an HTML, I'm going to make a head, I'm going to make a body. And then in here, I'm going to, in my body, I'll just put like a hello world. And then in my head, I'll stick a title and go fetch demo. Actually, I'm going to update this and go look in the console. Oh, crap. Yeah, attendance and break. Okay, we will, thank you for the reminder. Let's finish this up. We'll do all that stuff afterwards. I will say that it is possible our class might go a little bit long today. This is going to be a bit of a heavy one, but I want to get through all of this. I don't want to sort of like break halfway in the middle. So that's kind of why I'm just driving forward here. But yeah, we'll get through this and we'll have our break. Thank you though. Okay, so I'm going to save this. And then has Max talked about local development servers and sort of how you open your HTML file in the web page? How have you done that with him in the past? Oh, wait, there's like that extension that he uses, oh gosh.
If you expand the window a little more, it might show it. Or just click in the white space in the bottom, like I don't know what you call it, the taskbar.
Yeah, what's the name of there's like that extension.
Oh, right there, shared. I think if you click on the shared one, it might. No, maybe not.
No.
It's what it looks like on mine. If I click, there's also a quick key. I think it's Command Shift L.
I don't think that works.
So if you don't, you might not have the extension installed.
Okay. Let me see if I can.
I thought it was just live share.
Live server.
Live server.
I think this is what it is. Does this look familiar to you all? Okay.
Yep.
It's now on your bottom right. It's on your bottom right.
Yeah, the go live button.
Yep.
Yeah. Okay. Wonderful. So I should be honest with you all. I don't use VS Code every day. I am like not a big VS Code fan, and I like don't use a lot of the tools that Max has taught. So I appreciate the patience here. Okay, so now we've got our thing open here. Everything's great. We've got our stuff in the console, or we've got our page logging out look in the console, which you don't need to yet, but we're getting there. So I'm going to put a script tag just inline in here. You could make this a separate script src pointing to a JavaScript file, just for the sake of having this all in one file, all encapsulated in one place. I'm going to put it in line, but you wouldn't have to if you didn't want to. So I do this, and I come over here, got our hello world. Okay. Oh, I didn't ask before. Do I need to make this bigger at all? Either of these? If anybody, okay. I'm seeing some head shaking, so I'm just going to assume that I'm good there. Okay. So I'm going to pull out from over here our okay. So making my request, storing the response promise into response, and then we get promise here. Now, because response is defined globally, I can sort of like interrogate it in here. And we can see that now, actually like a few seconds later, it's fulfilled. We've got stuff in that box. That box has been filled up with the response data. And inside of here, you can see we have like a status code, and there's some other stuff in here too. It's kind of nice. So we're going to keep kind of adding to this file. I think, you know what? I think this is a pretty good stopping place. We've sort of got this file. We've got it making the request. We're going to need to get some more into promises, but I think it probably makes sense to pause here before we get really in the weeds, and then we can come back afterwards. We're not going to talk about cores today. Cores is part of a day in the following week, but we're going to talk about it eventually. Okay. What sort of word do we want to do today? How about oh gosh, what's promise? That's a thing we talked about today. The secret word for attendance is promise. Okay, so I think then let's take our break. I realize this is a little bit short. I just want to make sure we get through all of it. Let's maybe come back at like 7:30. I think that makes sense. So get back at 7:30. We'll finish up the promise stuff, and then we'll make a bunch of fetch requests over and over. Get some practice in. So I guess then I will pause this, zoom on the recording. So where we left off is we put together this little example here. When I go to it in a web browser, you can see our promise pending. And when I go to, if I log out response after the fact, or there we go, come on. I can see that after I give it a few seconds, the promise is fulfilled and data's in the box, the promise box. So there's an important thing, though, I haven't talked about, and that is, okay, it's great that there's stuff in this promise box, but we still need a way to like get data out of that promise box. Like, we need a way to like open it up and like pull the stuff out. The problem is it wouldn't really, we couldn't really do something like keep checking the box. So maybe as an example of what I'm saying, something you might think you could do is something like this. So have like an infinite loop, and then go like if response dot stuff in box, then like break out of the loop. Or maybe actually the way to write this, it would be a little easier to understand, is like this. And then like after this, you could do like response get stuff in box or something. Like conceptually, you could do something like this. The problem with this, though, is we've reintroduced our problem above, where we're sort of like waiting for data. We're like blocked. And we'd be blocked right here. So while this maybe makes a lot of sense conceptually, it's not going to work. We can't do this. What we really need is something more closer to like our set timeout. We need to be able to like somehow have the promise like tell us when it gets filled. We need to like invert that. So like just like the set timeout, we'll call a function, call that callback after a delay. We somehow want the promise to call a function after something shows up in the box. So you can maybe see how those situations are similar. Just one's the fixed delay, one's like when something shows up in the box. So there's a way to do this that you do a lot when you're dealing with promises. So there's this function, this method on a promise called .then that Max probably talked about a bunch with you all. So this won't work. This will work. So what I'm going to do, we've got our response, and our response is a promise. So this .then method available on a promise, what you can think of this method is sort of like a set timeout, but the delay on that set timeout is variable depending on when the data shows up in the box. When the data shows up, it comes back from the server, ends up in that promise. So I'm going to go response.then, and then as a parameter to my .then, just like my set timeout, I'm going to give it a function, a callback function. And then in here, I could do something like, there is stuff in the box. I could also maybe like log out response or something like that, so we could take a look at it. So I'm going to take this. I'm going to bring this over into my demo here. So right after fetch, and then this is, yeah, I think that'll work. Cool. Okay, so we've got this. So what should happen here? Should log out hello world. Then we should make a request with fetch to creators and code xyz/fruit, this endpoint. The promise that gets returned from fetch gets stored in this response variable. Then we'll log out this response variable. So keep in mind, the promise box is empty right now. There's nothing in it. Then we'll register a function with the promise with .then to run once data shows up in the promise. And then we're done. We just sort of wait here. And importantly, like the browser can go do whatever it wants. It can handle button to click events. It can handle resize events. It can handle redrawing out the web page. It can do all that stuff. And then once the data comes back from the server, it will call this function and will get logged out. There is stuff in the box with our response. And at this point, the response will be fulfilled. It'll have all the stuff in the box that's important. So I'm going to save this. If I reload it, you'll see we get what I was just saying. So we get hello world. we get the pending promise. And then after in the dot then, we log out the fulfilled, the promise with the stuff in the box with the response data. So the last bit that's important to know here is dot then also you can do one more thing with it that's really cool, which is instead of looking at the response here, dot then as actually a parameter to this function will give you the stuff in the box. So I'll go like data in the box. So before I save this, I just want to call out over here, we've got all this stuff, body used, headers, okay, redirected. So keep this sort of in your mind, this under this like promise result thing in the promise. So I'm going to save this. And when I reload it, you'll see now I've sort of pulled that out of the promise. I've gotten rid of that promise wrapper around that thing. So now I've got this value, I can just like access it. So I can do things like, I can do like dot okay. So that would be accessing the property okay on that. So if I save that, now we'll get true there because that's what was set under okay. So this sort of pattern of make a fetch request to perform an asynchronous action that returns a promise, then calling dot then on the promise and passing that dot then a function, and then in that function doing whatever you want to do once the request is complete, that sort of pattern you're going to see over and over and over. And it's a really important one to sort of familiarize yourself with. So this file here, I think is going to be a really good reference for you to look at if you want to think about the stuff sort of after we're done with class or next week while you're on break, you're just sort of like pondering all this. This, I think, should be a pretty good reference of like, here's an example of like what you would actually do in a real web application to make a request to a server with fetch asynchronously. Joe, you asked, so response.then gets scheduled in the event loop. Yeah, that's a good way of thinking about it. What's actually going on behind the scenes is a little more complicated than that, but I think that's like a good conceptual place to be, where it's scheduling that function, and then once, but it's scheduling it with sort of like an undefined point in the future. And then once that data shows up in the promise, it will then at that point execute the function. Importantly, though, that execution, that's all happening in the JavaScript layer. Like you're never calling this function you're passing to then. The browser, the JavaScript engine, the promise machinery, that's what's calling the function on your behalf for you. Okay, so that was a lot of stuff. You probably all want me to stop talking at you, and I want to stop talking at you too. I want to actually do some promise demos here. Let's actually get you all making some requests with fetch on your own. So okay, actually, let's see. Yeah. Oh yeah. I guess I'll just finish up these last couple slides here. So importantly, when you have a promise.then, anything you want to happen once the promise is done, is resolved, needs to go inside of the function. You can't do this. That won't work because response is being defined here. So first of all, just like this won't work because it's outside of this function. It's like defined separately. But it also won't work because you're trying to run this console.log immediately after the fetch call starts. So when you log this, even if response was defined here, the promise wouldn't be resolved yet, so you wouldn't be able to get the stuff in the box yet because the box is empty. So that you need to make sure that whenever you want to do anything, once the promise completes or once the promise resolves, once the fetch call completes, the response comes back from the server. If you want to do something once that happens, you have to put that inside of the function past a dot then. So Joe, you just wrote something in the comments or in the chat. You wrote console.log. Actually, I'll just copy it and paste it into here just so we can take a look at it. So this is what you typed. Can you sort of walk through what you have in mind with this?
I mean, I was kind of asking if that's like a valid format. Did I copy it down correctly instead of or no, probably not, right? Oh, I missed
No.
the response.status there.
Yeah, so importantly, the return value of promise.then, the return value of this highlighted expression is not relevant in the context of this discussion at the moment. It does have a return value, and it is interesting, and we might talk about that later, but it's not like the return value of promise.then is not going to log out like something meaningful here. Really what I think you meant is you want to take this console.log and you want to put it here instead. So something like this. So instead of wrapping the .then in the console.log, you want to put that console.log inside of the callback function.
Right, yes.
Because if you did what you did before, so if we went back to how it was before, what this is going to do is it's going to log out the return value from this immediately. It's not going to wait to log it out until the response comes back.
Right. Alrighty. Thank you.
Yep. Okay. There's one more thing I want to talk about, but I'm trying to decide if we should just do some of this because I don't want to keep giving you more stuff. I think we should just do one to start with here. Yeah. Let's start with this one. So what I'd like you all to do, I think you all have the VS Code Live share thing working. So I would like you to open up VS Code on your computer and make a directory and make an HTML file in there. Once you've done that, I want you to put this code. I don't want you to copy it. I want you to actually write it out by hand so you can make sure you understand what everything's doing. I want you to sort of transpose it into your file and save it and run it and see if you can get the same result that I got here. So importantly, what you're looking for is you're looking for one log with the promise pending and one log with the response data in it. I think this is week 11. Yeah. I'll give you a few seconds to go through that here.
Did you say what you wanted us to do one more time?
Yeah, so create a file in the directory you made for this. Inside of there, I want you to take everything that's in this file and I want you to transpose it in. Importantly, I don't want you to copy and paste it. So I want you to like make the HTML tag, make the head tag, go through the same steps I did to create it and sort of copy it over bit by bit. And the goal is after you do that, open it up and I want you to be able to see the same thing here. So be able to see like the log with the promise pending and the log with the response. So transpose it over and make sure it does the same thing. So if you were coding along with me, that's great. Congratulations. You're already kind of done. Yeah, I guess if you weren't coding along with me, I guess I'm giving you time to catch up to that point now. I maybe should have clarified whether I wanted you to do that or not. I guess it didn't matter either way, but um once you've gotten this all copied over, if you could give me a thumbs up reaction, just so I know you're where you are, that would be helpful.
If I want to test the OK, should I put it on the outside of the parentheses in console log?
Say that one more time. Sorry.
If I want to test to see like if my OK will pop up as true in the console, should I put it outside of the parentheses in the console log underneath the response dot then?
Yeah, so you want to make sure it's within the body of that function. You can either
Okay.
put it as an extra parameter to console.log or make like another console.log. Doesn't really matter. The important thing is just has to be inside this function.
Thank you.
Yep.
I've been doing a lot of Java homework lately, and I keep specifying my data types.
I will say, for anyone who is a bit more forward-looking, Max and I just had a discussion last night, and it sounds like I might be teaching you all a TypeScript lesson in a few weeks, so that should be fun. So, I'm seeing a fair amount of thumbs ups. Do people want more time, or do you have any questions, or how can I be helpful if you haven't gotten there yet? Nobody has any questions, I'll probably just keep moving forward because I want to make sure, be cognizant of time and get through everything. But if you have questions, seriously, let me know. Okay, so we've got this running here. You've hopefully been able to replicate what I've done. So what we have here in our script is effectively this first example. So method get path fruit headers none. So fruit get headers none. Let's go to the next one. So what I would say is take the file you have right now, the one that you created, make a copy of it. So you have a reference of both versions. And then the copy, I want you to modify it to make a request to this endpoint. I will say if you're really feeling adventurous, feel free to start your file fresh and go from scratch. Don't copy it.
So like I used GitHub to launch it. Should I just make a new repository, or you want me to keep the second folder in the same like?
I would say keep it in the same repository. That's probably the easiest way to go. Or even if you just made an HTML file, just make another HTML file in the same directory.
Okay. Thank you.
Yep. And just like before, if you're able to get that to work, give me the thumbs up reaction just so I can keep an eye on things. Okay, how's it going, folks?
What is the header for the body look like? Is it just body?
Yeah, let me pull up the. Actually, I think this is. Yeah.
Oh, okay. Those quotes.
I try to have it all up on my screen, but I only have so much real estate. So you might have to reference it on your own in the slides if you need that. Sorry. Also, I should probably be clear, this is supposed to be kind of a challenge. So if you're having difficulty, that's fine. Okay. Do you all want more time, or would you want me to go through it?
I just tried to
Anybody?
do one from memory, and the promise got rejected.
The promise got rejected.
Error failed to execute fetch on window.
Yeah. So let me just quickly explain what that is, and then I'd love if you could share your screen and we could take a look. So I talked about promises as a box, and then stuff goes in the box eventually. It's also possible for a promise to get into another type of state. So to be clear, the empty promise, the empty box is called pending, and the filled box is called resolved or fulfilled. You'll sort of see those interchangeably. There's another state, rejected, which is sort of like, imagine the promise fails, like the operation doesn't go right. In that case, the promise will go to rejected state. And think of that as sort of as like there's a value, the thing in the box, but it's like not what you expected. Like it's like an error, like a bad thing's in the box. So that's kind of what that means. But I would love to sort of take a look at your code and see what's going on.
Sorry, I was unmuted. All right, let me recreate what I just did because I just broke it. Well, I got a different one. We'll do that, I think. I failed to execute. I just changed those.
So
Okay.
take a look at the
Yes.
error you're getting. Read through it. It says failed to read the headers type. So I would like when I read that, my brain thinks like, okay, something's up with that headers value. So like that's kind of where I clue in. Take a look at the example I wrote and take a look at what my headers value looks like. Or the example you transposed.
Oh, BY. Hey, pretty close for trying to do it by memory.
Yeah, pretty close indeed. So yeah, headers has to be an object. It's sort of a mapping of keys of values of like header names to header values.
All right. Cool stuff.
But cool.
I
Anybody
have a
else?
question.
Yeah.
Trying to like do it a second time, and then I missed something, but I can't figure it out. Look, it's not like accepting my body. Is that incorrect?
You're very close. Take a look at line 14, the line above the line with the red line on it. So that this is a line in an object. In objects, you have a key and then a colon and then a value, and then you've got a comma afterward to sort of like separate all of them. What are you missing on line 14? Yeah, I bet if you save that, it'll work. Reload the page. Just that error might be superfluous.
Oh, did I misspell this? Careers and code XYZ.
I think you have 2 slashes. So slash
Oh,
text
on the
processing, I think you
text.
just want 1. Yeah, that's what it is. Cool. Yeah, that looks good.
Is it gonna
Okay.
do the thing?
Do
Oh,
what
sorry.
thing?
Like tell me how many words, count my words?
Well, we're gonna get there in a second. Not
Oh,
yet
okay.
though. And the fact you pointed out, that's good. So to maybe put the words you said there in another flavor, like what you're pointing out is you're going through that response object and you're not seeing there's a body in there anywhere. And that's like a little fishy. Like every time we've gotten response data back, we've gotten all the stuff like the response headers, the status code, all that. But we've also gotten a response body. I'm going to put a pin in that for a second. Does anybody else have any questions? Because what you just asked leads to the next thing we're going to talk about.
Can you run through it?
Yes.
Thank you.
Okay. So I'm going to make a new file. I'm going to call this frequencies.html. Put all this in here. Okay. I'm just going to update mine because I want to keep going kind of fast here. But so what I did here is this is my path, text processing frequencies. So that's what I got to put there. And then my method is post. So I'm going to update this to be post. So those are sort of those two parts. And then I've got to include a body. So my body here, the quick brown fox jumped over the lazy dog. I've got to include that somehow. And this is sort of the way you do that in Fetch. You got to give it that body key as that second parameter. In that second parameter. So I'm going to give it body. I'm going to put the quick brown fox jumped over the lazy dog in there. I also need to make sure I put a trailing comma there just so that we've got key value, comma, key value, comma. We've got those properly separated. Okay. I'm going to save this. Then I'm going to go over here and go to frequencies.html. So what you'll see now is I'm making a request to this. I'm getting back at 200. So things seem to be looking good. So the only difference from this and the last example should be right here in the fetch. In particular, the parameters passed to it, changing the string, and then updating the body and method. Does that make sense? Cool. Okay. So Deandra made a really good comment, which was that we don't have a way right now where we can get the body coming out of our response, coming back from the server. Like, we don't have a way we can get that. You dig through here, you don't see anything like that. I mean, you see body here, but like this isn't very helpful. You don't see like that text string. And the reason why you don't see that is there's, I wouldn't say I lied to you, but there's an extra layer here I forgot to include. And that is that, going back to that box analogy, we've got our promise, which is an empty box. And then when data comes back from the server and it gets put in that box, that promise box, in addition to that, another smaller box gets put into our box that is empty. So unwrapping the analogies out of there for a second, like what happens is, actually, in order to get the response body coming back from the server, there is a value available on our response object we get back that when we access that value, there's actually another nested promise inside that we've got to access to be able to get the data inside of the body. What does that actually look like? Let me show you. So this is sort of what we had before. This is what we need to do in order to get the data out of the body, or get the body data out of the response. That's what I meant to say. So I'm going to add this to our example here, the text processing frequencies one, so we can see what that looks like. Yeah, it's a little recursion-y. It's actually going to have some similarities to this kind of set timeout thing too, where we've sort of got functions inside of functions inside of functions, which is not great. And we can talk about at a future date kind of how we can undo some of that. But for now, we're just going to go with the easy, straightforward, it works way. So what I'm going to do, this data inbox value, I'm actually going to rename this and call this, actually, nah, I'll just keep it the same. I don't want to make it even more confusing. On this, there is a method called text. And if I call this, I will get a value that is like a response body promise. Also rename this to response promise just everywhere, so it's clear what that is. Okay. So we're going to add the same kind of thing. So data inbox.text, this returns a promise. This thing here is a promise. So what we're going to do is the same kind of thing. Response body promise dot then. And then when data shows up in this nested box, this nested promise, we're going to call that our inner function is going to get called. And what's going to get called in here is a console.log that prints out something like response body. I'm just going to call like this like body. And just like before, just like here, the parameter to this function is our body. So that gets stuck there. So if I save this and come back over here, you'll see we now have that response body we got back with Postman and with Netcat and with cURL. So I'd love if you all could add this into your example, either just copy it from my thing live, or if you need to copy and paste it, you can go for that too, I suppose. Ooh, great point. How that got there. Now that we have this in here, this is a complete example of about all you're going to need to do for the near future when it comes to making fetch requests in a web page. You're going to be doing something along the lines of calling fetch with some function parameters, getting a promise, calling then on that promise and passing in a function. And then when that function gets called, due to there being data that came back from the server, then you're going to call .text, or we might talk about some other things you can do, but you're going to get the response body out of the response coming back from the server. You get that as a promise, call .then on it one more time. And then once that promise resolves, you'll then get your response body from the server. So that's pretty much where fetch-wise, where we're going to kind of stop for today. Like this sort of sequence of operations here. Any questions on any of that? Okay. I think we should do at least one more of these. Yeah, let's do this. Let's do one more. And there's one more thing after that I just want to mention that's just sort of like tangential, and then I think we're going to be done for the day. I don't want to keep you all for too long. I'm sorry we're probably going a little beyond where we maybe should, but I appreciate it, and I want to make sure we get through all this before you go on your big break. Okay, let's do this one. So same thing, just like the other one, make a copy of your file, make it call it something else. So you have now 3 files, each with your different examples, and modify it or do whatever you need to do to sort of get it to make this request now instead. Importantly, this one does not have a body, but it has a custom header. So that might require some different syntax. But let me know if you have any questions. Okay, I see some thumbs up in the chat. I didn't ask for folks to do that, but thank you for doing it anyway. Anybody have any questions or want me to mention anything before I go through it? Okay, let me go through it. So I will make a new file here. Oops. So I'll call this one lockbox. Okay. So for this one, I need to make a GET request. So I'm going to update this to be a GET. And for this one, I need to make a request to /lockbox. I need to include some headers for this one. I don't need a body. So I'm going to get rid of my body. And in here, I'm going to put authorization. And then either the word super secret. So I'm going to start there. Okay. I'm going to save this. I'm going to go back over here. Looks like our response body was empty. Does that seem right? Yeah, I got a 201. I think that's right. Give me one moment. I'm just going to verify that that is right. Should know my own exercises. Sorry, folks. Yeah, there should be a response body. I thought there should be. What did I do? Let's see. Oh, I just didn't log it out. That would do it. So all I did there is I forgot to actually log out the body. So now if I come back over here, yeah, there we go. That's what I thought. Cool. I'm going to go over here and I'm going to update this. I'm going to make this like something wrong. Something like that. Now that I did that, see, I get that. Also, I just want to mention that when you make requests that don't get back a 200 or a status code that starts with a 2, Chrome will give you a log and tell you, which can sometimes be helpful if you're troubleshooting problems. So I just want to mention that that's a thing that Chrome does. Okay. I want to talk about one last thing, and then I think we're going to be done. Any questions any folks have before I talk about that one last thing? Okay. So there is something in Chrome that is really helpful when you're dealing with requests you're making with Fetch, and that is the network panel. So thus far in Chrome DevTools, you've probably talked about the Elements panel, and you've probably talked about the Console panel, maybe the Sources panel. The network panel, what this allows you to do is see all the requests that the current page is making. So as an example, I'm going to clear this. I'm going to reload the page. You'll see a few interesting things happen here. First of all, you'll see this first entry. This request is actually the request the web browser is making to the server to get the HTML page. So if you think about yesterday, how when I made that request with Chrome to like the netcat-l80 thing that was running, this is like that request. And you can see here that it gave back a 304, which actually I'm gonna do this. I'm gonna do this and you'll get back a 200, which will make a little more sense. There we go. So we're gonna talk about what 300s and 304s mean once we get back from break, but it's still successful, it's still good, but just different kind of good. 200, so okay, things went well. And you can see here, we've got all the response headers we got back from the server. If you want to see that unparsed, you can actually see the full body here, which is kind of cool. And you can also see the request headers. So all the headers that were included in the request made to the server initially, which is kind of cool too. You can also see the response. So like this is the data that the server sent back, which is pretty cool. You'll also note that actually this live server extension in VS Code injected some code into the bottom, some extra JavaScript. And so there's some stuff that's running that's related to that. This hook exec thing is some sort of Chrome extension I've got running in my browser. I guess it's doing something related to that. This is related to the request we made. We'll get back to that in a second. This here is something related to that live server extension. This is something called a WebSocket we're going to talk about next week, probably. This is another Chrome extension thing. Okay, there's a lot of noise in here. But right here, this is the request that's interesting. So when we made our fetch request, this is actually the request that was kicked off. So we can actually see things like, oh, this request was made to this domain name, this path. This was the response code. What's really cool about this is this allows us to effectively debug our applications. If I come down here and I do something like this, I make this like request with fetch, and I hit enter. You're going to see this shows up down here. So if I keep making like requests over and over, you'll get more rows in here. So this sort of like, I'm trying to like draw the link here where like this is sort of showing all those requests that are coming in, not just fetch, but requests that the web page needs to work too. So overall, this is an excellent debugging tool. You should know it exists. And it's also really cool because let's say you go to an application like maybe Google Slides or something that's like built in the web, and you're curious like what sort of network traffic is powering it. Well, you can inspect it. Any website you want. You can go to the network tab and you can reload this thing and you can just like see all the different network requests that are going on behind the scenes to make this application work. So the first request is always going to be that HTML, like getting that HTML content. And then in that HTML, there's some other stuff it needs too. Yeah, so for example, okay. Yeah, this freaking service workers made this hard to. Let me do this. I'm gonna do the same thing I did before and skip out from cache. Is that gonna work better? Okay. Yeah, that's gonna work better. Cool. So you can see there's a lot of crap it returns back. But this edit here gives me back a 200. This HTML. We get back all this HTML. Inside of here, we have things like this like shortcut icon. We have things like probably some CSS somewhere in here. I guess we've got this inline style, but I'll look for the shortcut icon. That's pretty easy to find probably. So like if I look through here, like all these sort of files are things that this page is requesting that are sort of like dependencies of the web app. For ICO. Yeah, I think this was our shortcut icon here, our favicons. This is what's showing up there. So yeah, anyway, I think this is often really interesting to look at to see like how other applications work and all the sort of fetch requests that are being made. Like here, it's type fetch. Like we can sort of peek at this and see how it works. So anyway, that's all I wanted to say on that. So importantly, that network panel in DevTools is a really helpful debugging tool for your own applications. You can use it to understand what sort of network calls your page is making. And you can also use it if you want to understand a bit more about how other applications work too, which is kind of cool. Okay. I'm, I think, done. I think I've touched on everything I wanted to touch on. Yeah. Any questions anybody has before we finish up for the day? Okay. So next week, you all are off on your summer break. I asked Max if there was anything I was supposed to tell you all before you left. He said that you should just go and have fun. So do that. We don't have classes next week. I know in the past, in past cohorts, we've had office hours on the weekends. Max said this cohort, there's been a little bit less of that. So I don't know if that's something folks are interested in. Is anyone like, does anyone have interest in having office hours this weekend? So like an hour or two. Okay, Terry, like an hour or two where it's me and you can ask me whatever questions you want about this stuff. Okay, seeing a couple positive signs there. If you've had them in the past, when have you typically had them? So like a time,
Early morning
like a morning, like
or
like
early afternoon.
Okay. Any preference anyone has on like Saturday versus Sunday?
I think when we took a poll, it was 10 a.m. on Sundays was the most.
Okay.
I
Cool.
don't, but we can do another poll if not everybody's interested in that.
I will be honest, I don't off the top of my head know how polls work in Zoom. I need to figure that out. I will say that 10 a.m. on Sunday would work really well for me. So unless anyone has a strong aversion to that, and if you do, it's fine, but just like say it. Like I think that's probably what we'll tentatively plan on. So I'll be in this call 10 a.m. on Sunday, and I'll be around for any questions anyone might have. If anyone wants to set up a one-on-one with me, I have a Calendly link. I don't know if Max gave you access to everyone's Calendly link stuff, but okay. I'll post it in the channel once I get back home. And I gotta dig it up and find it, and it's gonna take me a second. But I typically make my weekends available. I need to properly update that. I have a block of time this weekend I'm not gonna be available. Than that, I tend to be available on the weekends. Other than weekends, like usually I can usually make stuff work during business hours, like on a case-by-case basis. Like I work professionally, I can take that into account. But if it's like half an hour here and there, like it's not a big deal. I just need to make sure I can fit that into my other commitments. So yeah. Office hours tentatively on Sunday at 10. I'll do the Calendly link. I think that's it. Okay. Have a good break, folks, and see you when you get back in 2 weeks. Bye.